Welcome to General Nutrition class on Organic Chemistry 2. It's going to be the exam focus class. So in this class here, it's going to be a lengthy video. In this class or in this tutorial video, exam possible question video, we're going to look at what inductive effect, questions you likely see in the exam when it comes to what inductive effect. Then we're going to look at what resonance effect, questions you likely see in your exam. Then we're going to look at hyperconjugation what effect. Then after that, we're going to move toward the E and Z, which under what geometrical isomerism, how you can solve questions on that. After that, we're going to look at what optical isomerism, when it comes to what R and S, and how to identify optical what isomerism or enantiomers, distemers, and meso compound. So these are stuff we are going to focus on this video. After the optical isomerism, we are going to look at what the reaction of what of possible exam question when it comes to what ketones, anhydride, and alcohols. So this video is going to be a lengthy video, so you will want to stick to the end of this video. Now, I want this class to be very, very interactive. Now, the purpose of this video is that by the time you finish watching this video, yeah, they should have covered close to like 70 to 80% of your course. So what we want to do here, so like you're using this video as your revision, as overview revision. That's why I titled what general what revision, and these are the topic we are trying to do here. So you want to stick to the end of this video because majority of the stuff I'm going to do in this video, you will likely see them in the exam. And the good thing here is that I've made a tons of research about this topic here, and I'll be saying the exam. Believe me, these are stuff that are in your past questions and are in your textbook exercises. You will not want to stick to the end of this video. Now, if you are not subscribed to the channel, please make sure you subscribe to the channel. And I will be giving out a free PDF by the end of this video. I will tell you how to claim that free PDF if you stick to the end of this video. Probably to not get to the end of this video, maybe towards the middle of this video, which I want to give it at. So if you are ready for this class, leave in the comment section that you are ready and you are so excited to be part of this class. So before we start the class, please try to copy the link now you are seeing here. Copy the link and share it in your various groups. So please do that. I'll give you like 1 minute to do that. It's an online class, it's a free class in order for you to understand and prepare adequately for your exam. So if you have done that, please what you want to do here, click the link, like copy the link of this video here and paste it in your various groups so that your course mates who are also preparing for this exam can also be join the class. What you want to tell you is that make sure you join class. Can quiz have what serious online class, revision class that will be of help to them. So if you have done that, please leave at the comment section. If you are ready for this tutorial video, if you are ready for this revision class, leave at the comment section that you are ready. Leave at the comment section that you are ready for this video here. So if you have any question at any point, we have a live chat there. We have a live chat. So that live chat, leave your comment at that live chat. I'll be responding to that live chat there. If you have any question, I'll also respond to that. So let's move over this one here. You say inductive effect exam possible what questions. So here we have match the 4 pKa value of 1.24, 2.86, 4.05, and 4.82 with the following 4 acids. Now, this is a technical question. Now, butanoic acid, 2-chlorobutanoic acid, 2,2-dichlorobutanoic acid, and 3-chlorobutanoic acid. Now, one thing you want to understand here is that pKa determines the strength of what of an acid. Do you get that? pKa what determines what the strength of an acid. So pKa determines what the strength of an acid. And what you want to put in mind is that the lower the pKa value of the acid, the stronger what the acid strength. Please write it down. The lower the pKa value of an acid, the stronger what the acid strength. So if you are comparing two acids together, if you are comparing two acids and you know that what that pKa value, the one that have the lowest pKa value is what is strongest acid compared to the one that have what highest pKa what value. Do you get that? Here we have 4 acids here. 4 acids here we have butanoic acid, 2-chlorobutanoic acid, 2,2-dichlorobutanoic acid, and 3-chlorobutanoic acid. So I've already established stuff that the stronger the acid strength, the lower the pKa value. The weaker the acid strength, the higher the pKa value. So now you want to actually use the strength, use inductive effect to actually predict the strength of this acid here. So which I want to explain. if you understand all these things here, there's no question you see under inductive effect you will not able to what to answer. Do you get that? So let's get into it. Now, when you look at this stuff here, this is called botanic acid. I will draw a structure here. CH3, CH2, CH2, C. This is called butanoic what acid. Now here we have two chlorobutanoic acid. Here we have CH3, CH2, CHCl, C. You see that? Now here we have two dichlorobutanoic acid. So here we have CH3, CH2, right? And here we have three chlorobutanoic acid. So we put here CH3, CHCl, CH2. So these are the what? The four acids, right? Now, if you check me very well, you can see that they all have four carbon atom, one, two, they're all butanic acid. Now the only difference is what is the chlorine group here. Here we have this one is one, here is two, here is one is three. We have a call type of inductive effect. Types of inductive effect. We have called the plus I effect and what are minus I effect. I have done a complete video when it comes to what inductive effect. We explain what is the meaning of inductive effect and how you can understand inductive effect, the power of plus I and what are minus I effect. So if you have not watched that video, I would suggest you should go watch that video. Do that. So chlorine is minus I effect, minus I what effect, and we have a call power of minus I effect. So we see display on the screen, you see the various minus I effect group display on the screen. What I want to do here is to pause the video and copy them out. Do that. So what I want to understand here is that minus I effect increases the acidity of what of an acid. Right there. The more the minus I effect, the stronger what the acid strength. So if I compare two acid here and one is having minus I effect group like chlorine. Chlorine is what one of the major group in what minus I effect. Like what I said, minus I effect withdraw electron from the molecule. They decrease electron density in the molecule, and the more they decrease electron density in the molecule, the what stronger what the acid strength, and the easier the acid can what lose what an hydrogen. Do that, which I've explained what application of inductive what effect. So the acid that have the more plus I effect, the more minus I effect will be what stronger what acid. If you check me very well, this one do not have chlorine at all. So it's going to be the weakest acid. Do you get that? So it's going to be what? 4. The weakest acid because it does not have any what minus I effect. Do you get that? So now, if you check me very well, if you look at this guy, you find that this one is having two chlorine group, right? Close to the functional group here. Now, because this one is having two chlorine groups, this is going to be my highest acid strength. So this is going to be what my number one. Why? Because it's having two chlorine groups. If you check there, it's going to be lower because it's having what no chlorine group at all. Do you get that? Now this one is having two. They're going to be what my highest acid. Now the next is going to be this guy and this guy. Now the position of the chlorine group matters a lot when determining what the strength of the acid. You find that here chlorine is close to the functional group here. It's a carbon number 2, but here chlorine is not close. It's a carbon number 4. So instead that, another thing you want to put in your mind is that the closer the I effect to the functional group, the more or the stronger the acid strength. Now the position of the chlorine group matters a lot in determining what the strength of the acid. Like what I said, this is number 1 because it's having two chlorine group. You cannot compare the one that have two chlorine group with the one that have only one chlorine group. Do you get that? So this is the highest, this is what the lowest. Now these two, one is account number 2 and one is what account number 3. The account number 2, the chlorine is close to the functional group. But account number 3, the chlorine is a little bit far forward from the functional group. Do you get that? So the more the chlorine or the minus I effect is close to the functional group, the easier it can lose what hydrogen. Do you understand? So when you compare this guy and this guy, this one is going to be what the strength acid. So if here is my number 1, here is going to be what my number 2, and here is going to be what my number 3. It means that this guy is the strongest acid, right? Strongest acid. Now the second, the third, and the fourth. Do you get that? So the question should do what? Match the 4 pKa value with what following acid. Remember I told you that the strongest acid is going to have what the lowest pK value. Now, so the pKa value, the lowest pKa value is going to assign to this guy here. So here is going to be 1.24. Do you see that? Now, this what my second one here is going to have what 2.86. So the pKa value is going to be what 2.86. Now the third one is going to be this one here 4.05, and the last one which is going to be the weakest acid is going to be what 4.812. Do you see that? So the weaker the strength of the acid, the higher what the pKa value. The higher what the strength of the acid, lower what the pKa what value. Just that. So this is the what answer here. Now in the exam, they may ask you to what rank them in increasing order of what acidity or decreasing order of what acidity. Before I move on, let me explain that to you. If you shall be asked, so here's what is what is my strongest acid, right? My number one, you're going to be what my number two, you're going to be what my number three, you're going to be what my number four. Do you see that? So if they should ask you now, arrange them in what in increasing order of acidity. Increasing order of what acidity. Increasing order of acidity. Now, this is where so many students fail this type of question here, because if a student be asked or a question be asked, arrange group of atoms or molecule in increasing or decreasing order, student tends to what not to able to what to do that. Now it also like at times it also confused me here, but I have a simple method I want to teach you now that will be of help to you. Now, when you ask them like this, what about increasing order? Increasing order means what? From what lowest to the what to the highest, right? So we're going to start from 1, 2, 3, 4, 5. So from here to here is what is increasing order. Increasing what order? Please pay close attention to this one here. Is what is increasing order. Increasing order from the lowest to what to the highest. So it means that 1 is less than what 2, 2 is less than 3, 3 is less than 4, 4 is less than what 5. Do you see that? So if they should ask you now to arrange this what group of acid now in their increasing order, it means that I'm going to start from the lowest to the what highest. My lowest is what butanoic what acid. It's going to be butanoic acid is less than this that is less than the next one is what 3. Do you have 3 chlorobutanoic acid, 3 chlorobutanoic what acid less than the next one is what is 2 chlorobutanoic acid, 2 chlorobutanoic what acid. Then the last one is what is 2,2-dichloro, 2,2-dichloro what butanoic what acid. Do that. So in the exam, they will not say she what match. They will say in increasing order. Increasing order means what from the lowest to the what to the highest. This that. Now, what about if they say decreasing order? So for example, we have 5, 4, 3, 2, and what 1. You guys that is what is decreasing. If we as move from here to here, what happens is what is decreasing from the highest to what to lowest. For increasing order, this is what lowest to what highest, right? Don't confuse it. It's very less to the highest. But for this decreasing order, decreasing what order? It means what from the highest to the what lowest. Very important. So if they should ask now to what arrange it in decreasing order, then we're going to start from the highest. The highest was 2,2-dichloro, but we are going to use greater than sign. Thank you. We're going to use greater than sign, right? So 5 is greater than 4, 4 is greater than 3, 3 is greater than 2, 2 is greater than 1. So in increasing order, what will happen is going to be 2,2-dichloro what butanoic acid is greater than the next one is what 2 chlorobutanoic acid, 2 chlorobutanoic what acid greater than the next one is what is 3 chlorobutanoic acid, 3 chlorobutanoic acid greater than what? Greater than butanoic what? Acid. Very, very important here. So this is the what? This is the way they can what ask you in the exam. If you understand, please leave at the comment section that you are following and you get this other one here. You understand? So leave at the comment section. It's very important you do that. So with that idea here, we should be able to what answer question 2. Do that. They say classify in order of what increasing acid strength. Increasing what acid strength. So you can pause the video and see how you can try this one for me because these are stuff you may like listening to the exam. So pause the video and try this number 2 for me. So here we have ethanic acid. Ethanic acid is what? CH3C OH. It's called what? Ethanic what acid. Here we have 2-chloroethanic acid. So CH2BrO. OH here. So 2-chloroethanic acid. Here we have trichloroethanic acid. So tri Cl. Right? Then here we have fluoroethanic what acid? F. You understand? F. Then you have iodine. So you have H2I. So now the thing here is that you can see that there's what now when you checkmate it very well, these are minus I what effect group. These are what are minus I effect group. Do you get that? And we have recorded the order of what minus I effect. Look at something here. Fluorine is greater than what chlorine, and chlorine greater than what bromine, and bromine is greater than what ion D. Do you see that? So you need to understand this thing here. Now, this guy that don't have any minus I effect is going to be the lowest acid. Lowest acid. Now, when you check this one here, this character is having what 3 chlorine group. Automatically, this one is going to be the highest, number one. Number one. This is that number is going to be the highest. Why? Because it's having 3 chlorine group attached to what is second carbon. Do you get that? So yeah, we have fluorine, bromine, and what iodine. Fluorine is greater than what the any other one. So if you change by number one, you're going to be what my number 2. Now bromine is greater than what iodine, right? So you're going to be what my number 3 and what and number 4. They are going to be the lowest. You're going to be what my number 5. This is that. Now, the main reason why this is my number 1 because it's having what 3 chlorine group. You get that? 3 chlorine group will attract fluorine. That is only one. You get. Now, fluorine is either what bromine and what iodine. So that one is going to be my number 2. Bromine is either what iodine. That one is going to be my number 3. Now, this guy is my number 4. Is greater than that one here because it does not have any group at all. Do you get that? So this one is going to be what my lowest what acid. So now. They say classify them in increasing order. When we talk about increasing order, they are talking from what lowest to the what highest, lowest to the highest because you are using. I'm going to use okay. Now you are using what lowest to the what highest. 1, 2, 3, 4, 5. Right? So 1 is less than 2, 2 is less than 3, 3 is less than 4, 4 is less than what 5. Increasing what order? Increasing what order. This is increasing what order. So if you check it very well, so here is going to be what my number 1, you're going to be what my number 2, you're going to be what my number what 3, you're going to be my number 4, you're going to be my number 5. So because I look for from the lowest to the highest, so I want to start with ethanic what acid. So I can just swipe to arts. So it's going to be what ethanic acid less than ethanoic acid less than the next is what is fluorine. So the next is what is iodine. So going to be iodine ethanoic acid less than what is next? So we're going to be what bromoethanoic acid. So then less than here we have fluoroethanoic acid. less than this trichloro etanoic acid. Do you understand? So you can see as it is now. So this is for what, for the number two, right? Now the next one is what is number three. Look at what number three. Number three. Look at number three. Say, and when you follow amine in order of what, increasing basic strength. Now, amines are derivative of what, of the ammonia. If you look at ammonia here, we have NH3, right? Now, so here we have this guy here, hydrogen, hydrogen, hydrogen. See, now what make an amine a base? Because it can what, donate what, electrons. So any species that is capable of what, donating pair of electron or have pair of electron to donate are what, a base. Okay, so what make amine a base? Because it have what, a lone pair to what, to donate. Now, so if you check it very well, here we have the first one here, nitrogen, nitrogen with what, one hydrogen and what, three what, methyl group. Can you see that? Three what, methyl what group. So this called. So the first one is what, one hydrogen and what. So the first one is. So the first one is what, one nitrogen, two hydrogen and what, one ethyl what group. This is that. They have pair of electron to donate here. Here we have three of them. Nitrogen, CH2, CH3, CH2, CH3, and what? CH3 and what? CH2. This is that. Now, this one is having one methyl, one ethyl. This one is having what? Three what? Ethyl. Now, when you look at this other one, this one is going to have two. CH2, CH3, CH2, CH2, and then we have what? Hydrogen. This is this one having what, two of it. Then this one is having what, one methyl and then two hydrogen, right? Now what, here we have each of the structure here. Now this one is having one methyl group, this one is having three methyl groups, this one is having what, two methyl groups, this one is having uh one methyl group here. So you can see that now alkyl group are plus I effects. And when we come to what, to the strength of a base. Now a base plus I effects increase what, the strength of base. And the more the plus I effect, the stronger what, the basic was strength. So when you checkmate this very well, the one that is having three, the one that is having what, three alkyl, which called the methyl group, is what, is number one. Is what, number one. Because it's having what, three ethyl group. Now, this one going to be what, the second one here. So this is going to be what, second one. Number two, use that. Now, here we have methyl and ethyl. So here we have ethyl and what, methyl. Can you see that? So if you check me very well, ethyl is higher when it comes to what, plus I effect than what, methyl. If you checkmate what, the power of plus I effect, display on the screen here, you see that ethyl coming from what, methyl. Do you see that? So this guy is going to be what, the third, and this guy is going to be what, fourth. Now, if you check when the very say, arrange the following amines in order for increasing basic strength. Increasing basic strength means what, from the lowest to the what, highest, lowest, increasing like 1, 2, 3. So for the lowest to what, to the highest. Now the lowest one here is this guy here. So it's going to be C. So it's going to be CH3 NH2 is less. CH3 NH2 is less than, what is next one? The next one is what, is this one here. So here we have what, CH3 CH2 NH2 less than. Then here we have this one here, CH3 CH2 2NH, right? Then less than. Here we have what, CH3 CH2 3 and what, N. This is that. This is what they say what you should do. So I believe this video is helpful. Let's solve more question on our inductive effect, which I've seen in what past question. So now let's look at the last question under what inductive effect. They say which of the following compound will you expect to be a stronger what a strong base? Here we have the first one, here we have the second one here. So here we have phenylamine. So therefore, let's draw the structure what of phenylamine. This what NH2. This that NH2. This that. Now the next thing is what. So now nitro is accounted by what 4. So here we have NO2. Then we also have this one here, NH2, NO2. Now remember, this is what is a base. This is what is a base, and a base what will give out what the base what give out what the electron, right? Now here is what plus. Here we have minus I effects. Here we have what minus I effect. Do that. What you want to understand here is that minus I effect decreases what basicity. So whenever what a minus I effect is attached to what to a base, what that thing does, it decreases what the electron density. So this electron here is not really easily what available. Now when minus I effect is attached, do you get that? So here we have minus I, here we have what minus I. So the more the minus I effect is closer to the functional group here, or the group with what with the lone pair, the lesser what the basicity. Do you understand? Two of them are what minus I, here we what minus I. But here is a position what 3, and here is what is a position what position 4. Now, because they are not in the same position, one will tend to be higher than the what other one, or one will tend to be lower than the other one. He said that which of the following compound will you expect to be a stronger base? Now, because this one is minus I, and minus I effect decrease basicity, this guy is further away from this other one here. Do you see that? So because this one is coming by 4, and here is coming by 3, this guy is the stronger base, stronger what base, or is what now this one, now when compared to this other one, this one is a weaker what base. So when I compare it to now, the reason why this one is a stronger base because two of them have the same structure here, right? Now the thing here is that NO2. One's are coming by 3, one's are coming by 2. And two of them are what minus I effect. Minus I effect decreases what basicity. So this guy is closer to this other one here compared to the other one here. Now because this guy is closer to this NO2, which will have what the lone pair, is going to what decrease what the basicity more compared to the other one here. Do you understand? So this one is stronger base, weaker what base. That is for that one here. Look at what the B part. The B part here we have phenylamine. So phenylamine here we have NH2. This is called phenylamine. Then we have hydroxylamine. Now they both have this one here, but the difference is this one here. This one is what is a benzene group. A benzene group. Here we have a cyclohexane what group. It's okay. Cyclohexane. Now what I want to say here is that benzene is what is minus I effect. Now cyclohexane is what is plus I effect. Do you get that? So two of them are not the same. Minus I effect will decrease what basicity. If you check very well, minus I effect will decrease what basicity. Plus I effect will increase what basicity. So when it comes to what the strength of what now when it comes to what the strength of a base, cyclohexylamine is what is a stronger base compared to the other one here. The reason is because this is what the plus I effect nature and what minus I effect what nature. So this is higher than this, so you can circle out this guy. You can circle out what this guy here. So that is it for what inductive what effect. So the next one I want to look at what is resonance what effect. So let me to what review resonance effect exam possible what question. So these are type of questions you will likely see in the exam. So I have four questions here which I used to explain the concept. Now, what type of electron effect will operate in what 322 or Now, what you want to understand is here, what you want to understand here is that resonance effects occur in what? In unsaturated compound. Do you get that have what a double bond and it must be a conjugated what system. I have done a complete video on resonance effects, how to draw resonance structure. So you can still check it out if you want to learn it more. But what I want to do here is to what solve this question here. First, I want to do is to draw the structure here. So what our electric effect will operate in this one here is called resonance effect. Resonance what effects or mesomeric effects. It's okay, or what mesomeric what effect. So let's do a structure here. We're talking about pens. Pen means how many carat of 5 carat of 1, 2, 3, 4, 5. It's okay. Now, I count about 3. Here we have 1, 2, 3, 4, 5. I count about 3. I have what a double bond, right? And I count about 2. I have what carbonic functional period. This is that. So now, whenever you have a double bond in a conjugated system, then the effect that will result is called resonance what effect. Do you get that? So you have CH3, C. It's okay. Now you can draw a resonance structure where you can move some down and you move some up to get what a second resonance structure, which is CH3, C. It's okay. So this is called the second word resonance structure. In the exam, they will ask you to draw 2 resonance structure for them. Why? Because you want to that one here. I've seen it in the exam where they say draw 2 resonance structure or draw the possible resonance structure for what this compound here. The word possible what resonance structure. If you don't have to draw this resonance structure here, then I would suggest to you to go and watch what my complete video on how to draw resonance what structure. Do you get where I explain the various rules localize and localize of electron. It's very important to check out that video so I can understand the concept here. So there are 2 resonance structure. So that I got the word first one. Let me look at what the second one. Let's look at what the second one here. What type of effect will operate in what in this one here? So this one is going to be what resonance structure. Now, whenever I see a double bond, 2 double bond, you're going to have what resonance structure. Do you get that? Now, you can draw resonance structure. Resonance structure is just like what moving of the electron or the pi electron. Do you get that? So resonance structure, resonance effect, what will take place here? It's okay. Or mesmeric what effect. Now, what about they ask you to draw the second resonance structure or draw resonance structure for this compound here? So let me show you how to do that. CH2H, CH3 here. So if you want to draw the resonance structure, it's very easy here. You move this guy here, then you move on top here to get what a second what resonance structure. So to get a second what resonance structure, which is going to be CH. There you have this one here. And that you'll be confused or you don't know how I got from here. That is why I say you should go and check out my complete video because this is not the video I will start explaining resonance structure for you how to draw resonance structure. I don't have that time here to start doing all of those things here. That is why I will ask you to check out my complete video on resonance effect, the introduction aspect, where I explain the key aspect on how to draw resonance structure. So make sure you check out that video. It's very, very important to check out that video because you may likely they may likely what give you this one in the exam to draw the resonance structure. Do you get that? So the next is number 3. Phenol is acidic while ethanol is not because of dash. Phenol is acidic while ethanol is not because of what dash. The answer is due to what resonance effects. Answer resonance what? Resonance what effect. Now, one thing you want to put in your mind is that resonance increases acidity. An acid which conjugate base has a delocalized electron is more stable or more acidic compared to an acid which conjugate base do not have a delocalized electron. Do you get that? So you not be asked, you not be wondering what is delocalized electron. Delocalized electron means that they can move between what the molecule. Now, delocalized electron will relate to what multiple resonance or structure. If you check when the very well, this is called phenol OH, and here we have ethanol CH2OH. Now, when they both lost their what? When they both donate what hydrogen here, they want to form their what? Their oxide group here. You see that? Now here we call phenolzide. Here we have what? Toluene. Right there. Now, there's a resonance structure. Okay, phenolzide. So here, this is what this is what the conjugate base of this acid. This is what the conjugate base of this acid, and this is what conjugate base of this acid here. If you are familiar with what resonance structure, you understand that resonance structure occur at this point. Do you get that? We can have more than 2 or 3 resonance structure here, but here there's no resonance structure here. So the main reason why phenol is acidic and why ethanol is not, what I want to understand is that now an acid whose conjugate base has a delocalized electron, and any compound that has a delocalized electron will have what resonance, right there, will be more acidic compared to an acid whose conjugate base do not have a delocalized what electron. No delocalized electron here. If you check it very well. But there's what delocalized electron here. This don't have resonance structure. This one don't have what resonance structure. So it means that resonance increases acidity. You get that? So the more the resonance structure of the conjugate base of the acid, the more the stronger the acid or strength, or the more the acid. Do you get that? So this guy is acidic. This guy is not acidic because of what resonance structure in the conjugate base of what of the acid. Just that. That is the answer. Question 4. Explain why aniline is said to be acid, and phenol is what is not. Why? So if you check me very well, aniline is like this: NH2. Then you have OH. This is called aniline. And this is called what? Phenol. Now, the main reason why aniline is what is a base because it has what a lone pair to donate. So a base only have what a lone pair to donate. So any group or any compound that have a lone pair to donate is what is a base. Do you get that? So what make a base a base? It is the ability to what to give out what electron, and there's what lone pair electron here. Now, why phenol is an acid? Because it has what an hydrogen to what to donate. So in the postulate concept, an acid donates a proton, which we call hydrogen. So phenol donates what? Phenol donates what? Proton or hydrogen. Aniline donates what? Electron. That is what is the main reason. Now, but before we end what resonance structure, there is one that normally occur all the time. They will ask you that aniline is a weaker base compared to what methyl amine. Do you get that? Aniline is a weaker base compared to what to amine. Now, here we have amine here. It's okay. And here we have what? So here we have aniline. Here we have what? Aniline. And here we have what? Methyl. And just that both of them have this other one here, and both of them want to what give out electron here. Do you get that? Now, but this one we bring resonance effects. So what, like when I say what make a base, it is the ability to what to give out what electron right there. So the group that is directly attached to it, here we have this guy, and here we have this one here. There are two things that affect one here. Now you can either explain what in plus I effect or what resonance what effect. Now remember I told you that resonance increases what acidity, right? Resonance will increase acidity. So any acid that has a conjugate base that has a delocalized electron or resonance structure is a stronger acid. Now, but when it comes to base, resonance decrease what basicity. Right there, resonance what decrease what basicity, because if you checkmate what this guy have a resonance what structure. You get that? So now aniline is a weaker base due to what to the resonance effect group of what of the board benzene ring. And there's what the benzene ring has what we delocalize what the electron. Do you get that? If you draw the what together structure of this one here, you find out now because due to what to the benzene structure here, this electron is not easily what available to what to be donated. Why? Because this one will not make to be available. But yeah, methyl do not decrease what electron, it increases what electron density. So instead that this guy, the electron is easy to donate here compared to this other one here. Do you get that? So methyl amine is stronger base compared to what phenyl or aniline. Just now. So this guy is a weaker base, but it's a stronger base. Why? Due to if you check me very well, this one is what is minus R effect. It's okay, it's minus I effect. You understand? It's what is minus I effect. So and also what plus I will what effect, which I'm not going to. You understand? So this guy decreases what the electron density. The electron is not easily available here, but the electron is what is easily what available at this point. So the answer is due to what the resonance nature of what aniline, due to the resonance structure in aniline, making what the electron not to be easily what available. So that I got to be for it for what resonance structure. So let's look at what hyperconjugation effect. So let's move towards the hyperconjugation effect. If you are still with me, do in the comment section that you are still following this video and you're actually what getting a lot of value from this video. If you are actually what following this video, I understood what I'm actually what teaching here. Please now let me leave it at the comment section that you are still following this video and this video is what is helpful. It goes a long way to tell me that you are still following. Now look at this one, hyperconjugation effect exam possible question. How many hyperconjugable hydrogen atoms exist in this compound here? And how many exist in this word compound? So hyperconjugation only occur in what when there's a double bond. Now we have various conditions for hyperconjugation to occur. Now that one of the common ones you are also seeing in the exam is that hyperconjugation will occur when there's a double bond. Either there must be a double bond, and secondly there must be a alpha carbon. Do you get that? So here we have hydrogen here. So now for you to understand hyperconjugable hydrogen, there are some things you must take note of. Now for hyperconjugation effect to occur, there are some conditions that you must meet. Do you get? The first one is that there must be a double bond, carbon-carbon double bond. So the first one is that there must be a carbon-carbon double bond. I get. So there must be a carbon-carbon double bond. You get? And the next thing is what there must be a alpha carbon. And any carbon atom that is attached to the carbon that carry what double bond is called alpha carbon. If for example here if I remove here and I add this carbon here, then this carbon, then this carbon, then hydrogen, then this carbon, then this carbon. Now, if they should ask you how many alpha carbon do I have here? Remember, these two carbon atoms that carry the functional with main carbon, right? So any carbon atom that is directly attached to that carbon that carry what the double bond is called alpha carbon. So this carbon atom is directly attached to this carbon atom here, so it's called alpha carbon. Do you understand? And this carbon atom is directly attached to this carbon is called alpha carbon. This one is hydrogen. Hydrogen is directly attached to the carbon atom carry what double bond here, so it's at. This carbon atom is directly attached to this what carbon atom is called alpha carbon. So they should ask you how many alpha carbon do I have here? Yeah, this one is an alpha carbon. This one is an alpha carbon, and this is an alpha carbon. So here we have 3 alpha carbon here, 3 alpha what carbon. So the first category is that they must have a double bond. The second one is that they must have the alpha carbon. So when you are drawing a structure and they ask you about hyperconjugation, now the first thing you want to know, does the compound have a double bond? If yes, fine. Is there a alpha carbon? Fine. If there's an alpha carbon, there is a carbon atom that is directly attached to the carbon atom that carry a double bond. It's called alpha carbon. Then the last one is that there must be an alpha hydrogen. What do you understand by alpha hydrogen? Alpha hydrogen is that hydrogen that is attached to what, to the alpha carbon, as the word imply alpha hydrogen. Alpha hydrogen must be the hydrogen that are attached or that is attached to the alpha carbon is called alpha what, hydrogen. Do you get that? So in the sense that after having what, the alpha carbon, the next is that they must have what, alpha hydrogen. So if here I have what, two hydrogen here, I have what, one here, one here, here I have what, CH3, here I have what, CH3, here I have what, or maybe probably what, CH2, and here I have what, CH3. Now if you give this kind of compound in the exam, I say how many hyperconjugable what hydrogen do I have here? Do you get that? How many hyperconjugable hydrogen do you have in this structure here? Just like what you are seeing here. So in the sense that what you want to do here is to what, know my alpha carbon. Here's what is my alpha carbon. Here's what is my alpha carbon. And here's what is my alpha carbon. This is not alpha carbon. This is not what alpha carbon. Do you get that? So if you look at the hydrogen here, now the alpha carbon here, how many hydrogen does it have? It has what, three hydrogen. That hydrogen is known as what, alpha hydrogen. And alpha hydrogen also called hyperconjugable what, hydrogen. Hyperconjugable what, hydrogen atoms. Do you get that? So here I have what, three hyperconjugable hydrogen, which is what, three plus. Now this guy is having two because this alpha carbon here is carrying two hydrogen, so it's going to be plus two plus this alpha carbon here is carrying what, two hydrogen, which is what, two. If you add it together, seven hyperconjugable hydrogen. So this molecule here contains seven hyperconjugable hydrogen what, atoms. Very, very important. Seven hyperconjugable hydrogen what, atoms. It's very, very important to take note of this. Do you get? Now, this guy is not regarded as alpha hydrogen. Why? Because it's not attached to the alpha carbon. This hydrogen is directly attached to this carbon atom here. So it's not hyperconjugable hydrogen. Do you understand? So hyperconjugable hydrogen atom are hydrogen atoms that are attached to what, to the alpha carbon. And the alpha carbon, these are carbon atoms that are directly attached to the carbon atom that carry what, the functional group. This is the functional group here. Do you get that? So if you should look at this other one here, because this is what they say you should do. Let's try it out here. Yeah, the first thing I want to do is to what, draw the structure. Draw the what, structure. So here we have CH3, CH2, C. Look at something here. This carbon atom is having a methyl group CH3. If you check very well, this one is having the CH3 here, and this other one here, right? Then a double bond. Now, it's double bonded to what, to this hydrogen here, to this carbon here. This carbon is having hydrogen and what, and a methyl what group. So when you have a structure like this, the first thing you want to do here is to what, draw the structure like this. This way you cannot see or know how many conjugable how many alpha carbon you have here. How many what, alpha carbon you have. So look at this carbon here. That the two carbon atom carry double bond here, right? So this carbon atom, this one is already attached to it. So this guy is called alpha carbon, right? Now this carbon atom is directly attached to it. So you see alpha what, carbon. Now this one is not alpha carbon, right? Because it's attached to the alpha carbon. So it's not, you don't include it. Now this carbon here is having directly attached to this carbon, is directly attached to this carbon, right? So here we have two alpha carbon. Now let me move over to this other one here. This one is having carbon. So here we have alpha what, carbon. Do you get that? So here we have three alpha carbon. So here we have two, because this carbon atom here is having two hydrogen. So two plus this is having what, three plus what, three. So we're going to be what, eight hyperconjugable what, hydrogen. Conjugable hydrogen what, atoms. So here we have eight hyperconjugable hydrogen what, atoms. That is it. Eight hyperconjugable hydrogen what, atoms. Do you understand? If you understand, so leave at the comment section. We have a live chat there. Let's leave a comment at the word and live chat. Let's interact and live chat. Do that so you can communicate. You can communicate with other persons in the class through that live chat. I also respond in that was live chat too. Do you get that? So if this video is helpful, like you're actually getting ton of value for this video, please leave at that live chat. It's very important. So the B parts. How many hyperconjugable hydrogen atoms are there in one ethyl 2,3,5 dimethyl benzene? So let's check that out. So here we have 1 methyl 3,5 dimethyl benzene. If you look at benzene, this is called benzene ring. Are you here? So here we have 1 ethyl CH2 CH3, right? Now here we have 1, 2, 3, 4, 5, 6. Now number 3, I have what a methyl group. And here at number 5, I have what a methyl what group. Do you see that? Now, how to draw this thing very well so that you can get what I'm doing here. Now, benzene structure is like this: carbon, 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 carbon. Now, there's exactly what I'm doing like this, right? Now, there's a double bond here, there's a double bond here, and there's a double bond here. So, if you check here, you're going to be hydrogen. Now, this one is having what? CH2, CH3. Here we have what CH3. There will be what hydrogen here. Here we have what CH3. You see that? So you can see that the carbon atom giving up, they are all having what a double bond, right? So this carbon atom here have a double bond. So this carbon atom cannot be alpha carbon because it's having a double bond. Now this carbon here is directly attached to this carbon atom. So this is called alpha carbon. Alpha what? Carbon. These are going to be what alpha carbon, right? Because this carbon atom is directly attached to carbon atom that kind of double bond. The same thing is called alpha carbon. Do you get this? That? So how many hyperconjugable hydrogens do we have here? Here we have 2 plus 3 is 5 plus 3 which is 8. So this compound have 8 hyperconjugable what hydrogen what atoms. This is that. So it's very, very important to draw this structure because that is how you understand it. So this one is having 8 hyperconjugable what hydrogen what atoms. Do you understand? So that is it. Now I would like you to go ahead and try it for me. Pause video and try the question number 3. Which of these alkyl group we have the most hyperconjugable hydrogen atoms attached to a phenyl group? Now, you say that when you attach to a phenyl group, this is a phenyl group here. This is what is a phenyl group. So I want to write this out. So go ahead and try it. Is it A? Which one have the most hyperconjugable hydrogen when you attach to what? To the benzene group or phenyl group. So let me draw it out. Let me draw each of them out. Here we have CH2, CH3. Is it A? What am I saying here? CH3, right? Then here I have this one here, CH3. So go ahead, try some A, B, C, D. Now, so go ahead, try it. Which one have the most hyperconjugable hydrogen atoms? So go ahead and try it. Go ahead and try it. Go ahead. Send to the comment section. Which of these will have the most hyperconjugable hydrogen atoms? So go ahead and do it for me. Now, the answer is going to be C. C is what is the answer. Do you see that? C is what is the answer. Now, this is called alpha hydrogen. This alpha hydrogen having 2 hydrogen. Is that what 2 hydrogen here, right? This one is having 0 hydrogen. There is no hyperconjugable hydrogen here because if you checkmate it very well, here we have CH3, CH3, and what CH3. This alpha carbon do not have any hydrogen, so no hyperconjugable hydrogen. So here we have 0 hyperconjugable hydrogen atoms. Okay, 0 hyperconjugable hydrogen atoms. Now if you look at C, this alpha carbon here is having what three hyperconjugable hydrogen atom. Three hyperconjugable hydrogen. Right? Three hyperconjugable what hydrogen. Now this one is having only what one hyperconjugable what hydrogen. This is that one. So this one is having two, this one is having zero, this one is having one, this one is having what three. So this one is what is highest. So C is what is the correct one. Do you understand? So that is for what hyperconjugable hydrogen what atoms. So if you have any question, you can leave at the comment section. I will respond to that. If you have any question on this other one here that you think you don't understand, drop at the comment section. I will respond to that. So let's move over to what the E and Z is possible exact question. So I don't know if this is exact question I want to see in the exam, but if you are going to see questions in what geometrical isomerism, then you should be expecting questions like when it comes to E and Z. Do you get that? So it may not come in this format, or it may not come exactly this kind of question, but it may come in this format, the E and Z isomerism. Now, for those of you who don't understand the geometrical isomerism, who have not watched my first video when it comes to geometrical isomerism, where I explain what geometrical isomerism is all about, compound that possess geometrical what isomerism. And when you're being given different type of alkene, which one possess geometrical isomerism? I believe you're going to see that kind of question in the exam. I will suggest to you to watch what the introductory video when it comes to what geometrical what isomerism. It's going to give you what a broad understanding or better understanding in this other one here in what you're going to do. Yes. So let's get into it. They said give the structure of what E3phenyl 3-butenic what acid. So the first thing I want to do here is what draw the structure. Draw the structure of E 3 what phenyl 2-butenoic what acid. So this is what is the parent chain. But means how many carbon atom? But means 4 carbon atom. 1, 2, 3, 4. And there's a functional group here. Carboxylic acid what functional group. 1, 2, 3, 4. Now, alkane number 2 have a double bond. So that's why I say butene, not butane. So there's a double bond here. Alkane number 2. Then alkane number 3 have a phenyl group. A phenyl group. So this is what is the structure. CH3, right? Now here we have hydrogen. Now, when it comes to what E and Z isomerism, what you want to understand here is that E means what? Opposite side, opposites. Z means what? Same. Same what side. Is okay. Now, when I talk about E and Z isomerism, your focal point should be between these two carbon atoms that will carry double bond here. This is that. So these two carbon atoms carry double bond. You find that now this carbon atom is carrying this guy and this guy. So this carbon atom here is carrying two substances which called dimethyl and the phenyl. Now then this carbon atom here, you see that it's carrying two group here. Now it's carrying an hydrogen and a carboxylic functional group. Do you get that? So this is what you want to understand here is that these two carbon atom is the main point of focus. Do you get that? Then every other group that you attach to it, you need to pay close attention to them. Now, we have what we call priority rules. Now, the group that is directly attached to a single carbon atom here, you now look at their priority rules. Do you get that? So the one that come higher in when it comes to a sequence rule, you separate it out. If you look at this one here, carbon and hydrogen, they will tell you that when you are doing the priority, which are really suggested to pay close attention to, the sequence rule. Atoms with high atomic number take precedence over atoms with lower ones. If, for example, here you are comparing hydrogen and carbon, the atomic number is 6. The hydrogen, the atomic number is 1. So carbon will always attract hydrogen. So here you have hydrogen directly attached to this carbon here, then carbon directly attached to carbon here. This one will attract hydrogen when it comes to the sequence rule. I will go by it again. Now, these two carbon atom here, this carbon atom is having COOH group, right? And is that what a hydrogen? Now, when you have COOH group and hydrogen, this guy take higher priority than what than hydrogen. Just that this guy will attract this other will attract what hydrogen here. So in the sense that when you compare these two things here, this guy have what higher what priority, higher what priority. Is okay. So you mark it out. Then when you look at this other one here, methyl, you are comparing CH3 and a phenyl group. And a phenyl group. Now, phenyl has higher priority than what methyl. You get. So when you look at it very, this one have higher what priority. If you don't understand what I'm doing here, please leave at the comment section that I don't understand. But if you understand what I'm doing here, leave at the comment section that you understand, so that I can know how to explain more to you. It's very important. Probably before by the end of this video, I can send you the link to the other videos for you to go watch it here. So in the sense that when you look at this carbon atom, when you look at this carbon, these 2 points here, this can have higher priority. Do that. When you look at this other one, you also have what higher what priority. So our point of focus is going to be this guy and this guy. You get. Now the rule says they say it should be what in E. Now when you talk about the E means what opposite. E means what opposite. So I want to write this out. So look at this carbon atom here. This carbon double, right? Now remember, we're talking about the opposite. That is, this guy and this guy should be on the opposite side, because this carbon atom here, when you compare methyl and phenyl have higher priority than methyl. So you are saying this one here. This guy and this guy, which to our COOH, our OH, our hydrogen, they have higher priority. Do you get? So this and this guy should be on the opposite side. So if you want to go and take, you can do it like this: COH here. Then you have what a phenyl group here. They are what CH3 and what an hydrogen. So this guy and this guy now on what on the opposite side. This what they say should draw. Give the structure of E3phenyl 2-butenic what acid. This is what is the structure to ensure that these two that have higher priority are on the opposite what side. Now, as we say, she want draw the Z isomerism. So she want draw the Z isomerism. Like what I said, Z means what? The same side, right? The Z isomerism will be like this: CH hydrogen here. Here we have what? So these two are on the same side. This is called what? The Z. Now these two are on the opposite side. The area is E. So, but before we place those groups here, we must first check if the one that is having higher priority. This guy attract hydrogen. That's why you circle it out. This guy attract methyl. That's why you circle it out. So these two, the higher priority on the different carbon atoms that carry double bonds. Now they must be on the opposite side. It is what is E, and they must be on the same side. It is what is Z. Do you understand? So that is it. Let me write here: Cl, CHU, CHU, C. They have CHU, Cl, CH3. It means that this carbon here we have Cl, that is CH2, Cl. Here we have what CH2, C. Now this one here we have Jesus. Must be easy to worry no further. Now let me know the second one. Here we have Cl, CHU, CHU, C. Then carry up with CH, Cl, CH3. Then here we have this one here. So therefore, let's draw the structure out. Cl, here we have CH2, CH what 2, then C. Now here we have what CH, Cl. Here we have what CH what 3, double bond, right? Here we have what CH3, and here we have what CHCl. Now, when something like this gives to you, fair for you need to what draw the what you need to what draw the structure out first. It's okay. You need to what draw the structure out, and this is the structure here. So These are the two carbon atom here, right? That is what two carbon atom here. If you look at this one here, this carbon atom is having a methyl and this other one here, chloromethyl. Now, because of chlorine here, this guy is higher, having higher what priority, having what higher what priority. Do you see that? Now, if you look at this carbon, now this one just like a carbon C2 Cl. Here we have a CH2. This is that, and this one just like CH Cl. There we have CH3. So if you checkmate it very well, these two are not the same. They are not what? They are not the same. Now, this one here is having chlorine at the first carbon. Do you get that? Like this carbon atom here have what? A chlorine and a methyl what group here, right? But this one, if you checkmate this one here is having a hydrogen. Is that what? Is having hydrogen and what? CH2 and what? Cl. So let me say that this guy have what? Two hydrogen and what? One carbon. This guy have what? This one have what? One hydrogen, one chlorine, what methyl. So this guy is of what? Higher what? Priority. So that is why you know what master what the priority rule. If you are still confused about the priority rule, then you know what checkmate what the priority is here. So if you checkmate it very well, this carbon atom here, this one is having the higher priority. This carbon atom, this one having what the higher what priority. So they say she will draw the E and Z, E and Z. So first and foremost, let's draw the Z. When you draw the Z, these two should be on the same side. So I can draw it like this. CH3, CH2Cl. Here you have CH, here we have Cl, here we have CH3. And here we have CH2, CH2, here we have Cl. Do you see that? So these two are the highest priority, are they on the same side. They can either be down or up. Then now because they're on the same side here, this is what I call Z. They say use the sequence rule and the E and Z system. Name the following. Do you get that? This is it here. Then let's draw the E. The E is going to be like this. CH2Cl. Here we have CH3. Then here we have CH. Here we have Cl. Here we have CH3. Here we have Cl, CH2, CH2. So you can see that these two are on the word opposite side. So it's going to be what my Z. So that is it for this other one here. Now at times you can also be given a structure like this and she will assign the E and Z to it. You understand? So let me show this other one here. Give the structure what 2E 4Z heptadiene. Hepta what? Diene. So if you look at question 3, question 3 is a little bit more difficult. 2E 4Z heptadiene. Hepta. So hept means 7 carbon atoms. 1, 2, 3, 4, 5, 6. 7. 1, 2, 3, 4, 5, 6, 7. Right there. So I can mark 2 have a double bond because when you talk about diene means what? A double bond. A what? A double bond. So I can mark 2 have a double bond. Then I can mark 4 have what? A double bond. Do you see that? So here I can say CH3, CH double bond, CH, double bond, CH. Here we have CH2, CH3. Now this is the what structure. Do you see that? Now they say she will give the E and Z isomerism. Now this is what is a little bit confusing and complicated. So therefore we have to focus on this guy. You understand? We have to focus on this guy here. Then at number 2, it must be what? E. It must be what? E. So if you should focus on this one now here, here we have a carbon double bond carbon here, right? Here we have what? A methyl group, and here we have what? Hydrogen group. Do you get that? So please follow closely here. Now because we are talking about E, it means that it must be on the what? Opposite side. If you check very well, this carbon here, I'm done with that one here. So this one have what? A methyl and what? An hydrogen, right? These two here. Now this guy have the highest priority. right? This guy have what the highest priority. That's what you want to take note of. This guy have what the highest priority. Now, because I'm talking about the at the position two here, following close here. Now, anything that is coming to this side here, the high priority should be on the opposite side. Now, this guy have a hydrogen, right? Remember, hydrogen is always least. Then we have the whole of this guy. We have the whole of this guy here as what as the group that have the highest priority. So I can draw it so like this: CH double bond CH2 and CH2, right? So that is, yeah, I'll consider this one as one, as what? As one. So this carbon atom here is having hydrogen and what? CH3, right? So they are what? On the opposite what side? They are on the, so I'm done with what this idea. But account number four, it must be what? It must be Z. So what I want to do here is that I will pick this guy. I will pick this guy. At this point now, remember I'm done with that one here, right? This one still have double bond. So what am I going to do here? I'm going to wipe some arcs, right? Because I've already said it down here. This one is already at the top. Kind of what a double bond, right? Kind of what a double bond. Remember, this point is having the one of this one here, which I've said to there what then what a hydrogen. Do you see that? Now, this the only one will be regarded as what as one group, as what one group. So I have this other one here, carbon. Remember, I have hydrogen and I have what CH2, CH3 here. Can you see that? So I'm done with this one is my two, right? We just say what is Z. We saw two E, right? Now if you look at it very well, the H and what CH3, they have the highest priority. Hydrogen should be here, so I just want to have higher priority. So they are work opposite side here. But I want to get my four. My number four should be what Z. Then which is this other one here? Remember this one, this carbon, which is this guy here, is having hydrogen and the whole of this other one here, right? Now, if I'm talking about the Z, that is this guy and the highest group in this side should be on the same side. So if I should look at this hydrogen here, look at this carbon here, right? This carbon here, which is this one here, having hydrogen and the whole of this guy you read as one. Now, if you look at this double bond here, carbon here, now hydrogen should come here. Why the whole of this one should come down? Now, do you know the reason why? Because these two, now because this carbon here is having hydrogen, this will have higher priority, higher what priority, right? This will have higher priority. They also have higher priority. So at this, yes, my carbon four, which is what is the what two what E, right? Now at this carbon four here, 4Z. Now these two should be on the same side, right? Because this will have higher priority, this will have higher what priority. This is the structure they asked us to draw. Give the structure of 2E, 4Z, hepta. So this is the structure. So I count back two, like the two at this point here is what is E. Why? Because this guy and this guy are opposite side. And these 2 points here is Z. Because this guy and this guy have the highest priority and they work on the opposite side. Do you understand? So it's a little bit what trickish and what technical. So this is structure. Now, you can be given the structure, I say assign E and Z, but it's very rare. Most of the questions in the table, they'll give you something like this. I say, you got what the structure. And this is how to do it. Now, if you understand, please leave at the comment section down what you understand. Your own is what get more problem and solve for yourself. That is for what for the E and Z isomerism. Please, if you don't understand this topic here, I will advise you to check out my playlist on my complete video on what E and Z isomerism. That is when you understand this better. I'm just trying to solve exam possible question you see in the exam. So that is for E and what Z isomerism. The next one I want to look at is optical what isomerism.